Okay, so some of you have just been, I've given a bit of an overview of what computer science is, but I'll start with an idea for computer science, just to give you a feel for sort of what it might be other than just writing programs. And so actually I'll get a volunteer up for this. This is just someone who feels like being a volunteer. It's not a volunteer, you get shoved like this. Thank you, come on up. Thank you, brilliant. Okay. What's your name? Anna. Okay. I've got some cards here, and I'd like you to stick them on this board over here for me. And they're real on one side and white on the other. And I want a 5x5 square of them, and just put a few gaps between them and mix them up. So random mixture of red and white. Yeah, is it 5x5? Important in computer science. It's the fundamental unit of everything that's stored on a computer, which is that we only store two values. In this case, red and white. Anyone know how it's normally represented? Yeah. 0 and 1, yeah. Actually, computers don't store zeros and ones anywhere. We just call them 0 and 1. But it's actually things like high and low voltages inside the computer and stuff like that. On a CD, does anyone know how the computer reads? Like there's billions, literally, of zeros and ones on a CD. Anyone know how it reads the zeros and ones off the CD? Oh, that's cool. Maybe a little closer. So yeah, that's cool. Like quite a bit closer. Yeah, that's perfect. Well, just killing time while they're working out how it reads zeros and ones from a CD. Anyone used a CD? Yeah. Okay. So a CD player has something inside it. You're not meant to look inside because? A laser. So what's this laser doing to your CDs? It's reading. How does it read? Yeah, well you don't want to etch on, if you buy a CD from the warehouse and you don't want it to get etched by your laser, so, although if it's a blank one you want it etched. Okay, so it's shining on the CD, how would it tell between a 0 and a 1? Yeah, whether or not the light reflects off it, okay? So it's just going along and it's reflecting and not reflecting and so on. So what Anna's put up here is a whole lot of these zeros and ones, otherwise known as a binary digit, okay? Because we only count up to 1. You know the short word for binary digit? The first two letters are binary, the last letter of digit. B-I-T, bit, yeah, it's one bit. A byte is 8 of them together. Perfect, thank you. Okay, that. Just stay up to one side. So we've got a whole lot of bits here that Anna's put up, and I'll just add some more to make this a little bit harder. And so this might, absolutely everything stored on a computer is represented using zeros and ones, right? Every file that you open, every file that you download, every web page you look at, every movie that you play, every CD that you listen to, it's just a whole lot of zeros and ones. And so we've got here a bunch that Anna's put up on the board, and if that had been a CD and I went to put it inside a CD player, if one of the zeros accidentally changed to a 1, like if a bit of dust landed on it or it got scratched or something like that, then it would just read in the wrong information. And so if it was like a spreadsheet that said how much I was going to pay you, it would just have the wrong number. Okay? Yeah. It's probably, could well be. So here's the solution. Well, let's see if it works. And I'm going to get you to simulate a bit of dust or something landing on this CD here. Just flip one of the cards over. So change a red one to white, or maybe a white one to red, but just one. Okay? While I'm not looking. So she flipped one over? Okay. So if that gets put inside a CD player, the CD player, when it reads it in, needs to be able to look at that and go, hang on, there's something wrong with that. Right? It won't just use it. And even better, it needs to put it back to how it was. So is that the one you flipped over? You actually looked a little impressed then. Okay, so how did I do it? Memory, really good memory. I wish, yeah. It checks up, okay, yeah, it was. So what I had done is I'd added some bits, and I said I was making it hard, but I wasn't really. What I did is I made sure that the number of red ones in every row is an even number, okay? So is that an even number? I've got 4 red ones, that's even. So what colour do I put here? White. Leave it as an even number. What colour there? Red. So now there's an even number of red ones there. What colour here? Red. Okay. And what colour here? White. White, because 2 is an even number. Okay. And I did the same vertically, so I made sure there's an even number in every row and every column. Okay, and I'm going to get you to look away now. Exactly. And we'll flip one over. I'm going to make sure she's not looking, but also make sure you know which one was flipped over. And okay, you can look at it now. Now, there was an even number in every row, but the one that got flipped over, well, is there still an even number in this row? How about that row? Okay, so something's gone wrong with that row. Okay, let's try the column. Is that got an even number in it? Is that one? That one hasn't, no. So something went wrong in there. So which one did I flip over? Excellent, she got it. Okay, yeah. And you thought I had an amazing memory. As a thank you, there's a pack of cards that you can do the trick with. You can actually do that with any size at all. In fact, here I've got, this is a group of students in Christchurch who did this trick with one of those packs. It's 10 by 10, so there's 100 cards there. This is a few months ago in a different island, and one of those cards is flipped over. Anyone pick which one's been flipped over? Just to make it a bit easier, I'll label the rows and columns. Got one more pack to give away. Cool. Who said G6? Okay. And who said G? Because that was close enough to me. Yeah. The row 6 and column G have an odd number in them. So you can actually detect months later that one of those had been flipped over using that technique. So this is a technique in computer science called error correction. Every disk that you use, every file you download has error correction on it, because otherwise you just could end up randomly working with wrong data. In fact, I added 1 bit to every row. Typically they add about 3 bits to every row to be really sure of being able to correct it and detect that something's gone wrong. So that's just to give you an idea of the kind of things that computer scientists think about, other than just how do I write a program to do something. If you just wrote a program to work with data, then it may well end up not working properly. So let's just sort of talk about the kind of things that computer scientists worry about. So programmers worry about creating software, but computer scientists want to do it so that it's fast. And if you're in the last session, I was talking about how fast, right? 0.1 of a second is getting to be too slow for most people. It has to be really reliable, because if it keeps failing, people aren't going to use it. It has to be easy to use. It has to be what the customers ask for. That's why people who are good communicators make better computer scientists, because they're good at hearing what people are actually asking for in their software. It has to be really secure. Anyone heard of a company called Weebly? It's sort of a competitor to TradeMe. They started up about a year ago. They lasted for about 24 hours because they didn't know how to store information securely. And so all the passwords that people typed in when they got an account with them, someone got hold of them really quickly because they didn't use proper security systems. And they had to shut the site down and tell everyone to change passwords and all that sort of stuff. Okay. They've actually just started again, so they've obviously figured out the security thing. Often intelligent, if you're typing in a Google search, quite often it will have a good guess of what you're wanting to search. And that guess actually involves things like what country are they in, because often what you're searching for will be quite different depending on what country you're in and so on. You know, if I type in something like Chinese restaurant and I'm sitting in Christchurch, then I don't want, you know, the name of a restaurant in the middle of China probably. I want one that's near where I am. And so there's all sorts of things like, well, what else has he been looking for recently? What locations has he been at recently using Google Maps and things like that? Trying to make some intelligent guesses at it. Usually very visual. And these days, low power consumption is really important. If you have programs that are taking a long time to run and they're using a lot of power, then people get flat batteries on phones or laptops and things like that. And again, people prefer it if it's very efficient. So these are the kind of things that computer scientists worry about. Let me tell you about a couple of our graduates. So Craig Neville Manning came from Blenheim, and he did an honours degree at Canterbury and spent a couple of years working, did a PhD at Waikato, and ended up at Stanford University in the States working on the Human Genome Project, actually. This is a wee while back when they hadn't actually figured out how to sequence the human genome. He ended up as a professor at a university over near New York called Rutgers, but then he had a sabbatical leave at Google in San Francisco, and at the end of that time they said, actually, this is going really well and we'd really like you to work for us. And this is when Google only had a few employees. Okay, so he was you know, very early in on Google. But he actually said, no, I actually want to live in New York and you're in San Francisco and it's not going to work out. And their response was, okay, we're going to start up a department in New York, go and hire some people. And he now runs the engineering division in New York, and last I heard he had several hundred people working for him. And he still comes back to Blenheim every so often in Christchurch and catch up on what's going on. But amongst other things, Craig invented Google's define. So I don't know if you know, but if you type into Google define : and then type in a word, it'll give you a definition of it, okay, which is quite different to search for that word. He also came up with a thing called Frugal, which compared the prices of a whole lot of things that were advertised online, and Google Health Alert. I don't know if you've come across that, but it's kind of cool. This is a map that I grabbed yesterday of people making queries about flu symptoms on Google. And you can see that it's kind of yellow down in the southern hemisphere and green up in the northern one. Yellow means there's a lot of people asking about, you know, temperatures and fevers and things like that. And New Zealand is actually quite strong at the moment. And that is the Google Flu Trends map. Now, what happened is that when Craig first developed the system, they had this. They were measuring the number of queries that people were making about the flu. And this is back in 2007. Now, the blue thing, stop this for a minute, the blue line is Google queries about the flu, and the yellow line is reports by doctors to the National Centre for Disease Control about the number of flu cases that they've had. And it takes 2 weeks for doctors to report to the, for the reports to be coordinated. So around about January, which is the middle of winter for America, Google noticed, you see it here, hopefully, that suddenly there was a spike in the number of people asking about symptoms for flu. And they called up the CDC and said, hey, we think that the flu season just started today. And CDC said, you can't know that, we won't know for 2 weeks. 2 weeks later, the data came in from the doctors and said the flu season started that day. So just by analysing the queries that people were making in Google, they were able to track disease outbreaks and exactly where it is, because they know where people are making the queries from. So not just the country, but this state or this city is having a big problem. And so you could imagine being able to track things like food poisoning and all sorts of stuff like that, just based on what people are making, what queries people are making. And of course other stuff, like where rock bands are visiting and all sorts of interesting things like that too. So again, just a guy from Blenheim had this idea, maybe we could, use all this data that we've got to actually basically get flu supply, supplies to the right place at the right time. In terms of jobs, just in case you need any convincing, CareerCast do a survey of what are the best jobs, and the top job last year, they haven't done 2013 yet, was software engineer. It's working in teams developing software for people. Basically, the work environment is really good, and I don't know what your image is of what software engineer working environment is, but these days it is designed for creativity. They want their people to come up with really cool ideas. So, like, one thing Craig did when he set up his thing is they went and bought $10,000 worth of Lego. I think it's $12,000 worth. And they just got a Lego room. And so if you're feeling bored, you can go and hang out with people and play with Lego. And then there's a Guitar Hero room, and there's a, they try and set it up so that you just feel really creative. When you're working there and you come up with ideas, it's not about sort of, and they make sure their employees don't work too long hours. Okay, if you're working more than an 8-hour day, 5-day week, then they get a bit worried that you're going to lose your creative edge. Okay, they want people who are out and about. By the way, at Google, they kind of lead the way, but 20% of your time you have to work on your own project. So 1 day a week, or a few days a month, you have to do something that you're interested in that's not for the company. And a lot of their new projects come out of that. So if you're a mountain biker, you might think, oh, let's use Google Maps to do mountain bike trails. Or if you're a dancer, let's come up with some system for using Google information to help with dance planning, something like that. And so they're really interested in tapping into people's creativity. In case you're wondering, the second top job is being an actuary. That's, calculating insurance premiums. Work environment's not great, but the hiring outlook is amazing. Okay, makes up for it. HR, again, easy to get a job. Dental hygienist, same thing. Easy to get a job, and so on. But if we go back to the software engineer, it scores well on everything. Like it's pretty easy to get a job. It's not too demanding. The stress is quite low, which is not how it was 10 or 20 years ago in software engineering. It used to be a really high stress area. And the environment. Companies just try and outdo each other in making it the coolest place to work, because there's such a shortage of software engineers that you have to be cooler than the previous place, or else you have to pay a higher salary. And it's easier, it's cheaper to be cool than it is to pay high salaries. Though generally they do both. So this is at Google, so it's not too different to a lot of work environments. Very open plan. It's very much about communicating with your team, just being able to yell over the corner, say, what do you reckon about this? And a lot of opportunity for people to get together, hang out. Google are famous for putting slides in around the place, just because that's fun. The New York one have got a fireman's pole. And one thing that's really common these days is what's called stand-up meetings. In terms of the number of people doing computer science and software engineering, this is from America, but the same thing happened in New Zealand. Around about the year 2000, there were heaps of people enrolling in computer science, and then it plummeted. And in the first 10 years of